When you walk up to a vending machine, there's this very clear, very comforting expectation of how things work.
Right. It's totally predictable.
Exactly. You drop your coin in the slot, you press the button for your favorite soda, the machine whirs, and your drink drops down. It's a simple, closed loop, a transaction.
You pay, you get the product.
Yeah, and for the most part, when everyone listening to this right now sits down at a computer or, pulls out a phone to use an artificial intelligence tool, you probably think you are interacting with the ultimate digital vending machine.
Oh, absolutely. That's the default assumption.
You type a query in, you hit enter, and you get an answer out. Transaction complete. But what if the vending machine didn't just give you a soda?
What if it watched you?
Right. What if, while you were standing there, it logged exactly how long your finger hovered between Coke and Sprite? Or recorded the specific time of day you felt thirsty?
Or analyze the cadence of your button presses.
Exactly. And then sent all of that behavioral data to a global network of factories to fundamentally change the recipe of every soda manufactured from that day forward.
It's a wild thing to think about.
It really is. Welcome to the Deep Dive. Today, we are unpacking a really fascinating slide deck titled The Data Economy Behind AI. And our mission for you all today is to trace the invisible, highly lucrative journey of your prompt from the exact second you hit enter to how it actively fuels a multi-billion-dollar global economy.
Yeah, and to do that, it requires a pretty profound shift in how we understand our relationship with software, honestly.
Definitely.
As we pull back the curtain on these systems today, the goal is to help you see the hidden architecture operating right beneath the tools you are likely already using. The core theme established right at the beginning of this presentation is a reality we all kind of have to confront.
Which is that our prompts don't just disappear.
Right. Your prompts do not just vanish into the ether once your question is answered. They become raw material. They become training data. They become commercial products. And ultimately, they drive profit. Understanding the mechanics of that transformation is absolutely critical for anyone navigating the modern digital landscape.
Okay, let's unpack this because the opening sections of this deck are designed to completely shatter that vending machine illusion we just talked about. They explicitly call out what they label the missing piece.
The missing piece of the puzzle, yeah.
We tend to assume a straight line, like prompt in, answer out. But the visual provided here illustrates something entirely different. It is not a line at all. It is a continuous, never-ending loop.
And the mechanical reason for that loop is really the foundation of the entire AI economy. We have to stop thinking of AI models as static databases or traditional search engines.
Right. They aren't just looking up facts in an encyclopedia.
Exactly. They are statistical prediction engines. And for a statistical engine to remain relevant, it requires a continuous, immense diet of new information. The continuous loop operates in 4 distinct mechanical steps.
So step 1 is just you asking the questions, right?
Right. First, you ask a question. But when you hit enter, that prompt isn't just a query. It's instantly serialized into a data node. Then second, the system collects that data. It logs your syntax, your context, and the specific parameters of your request.
Wow. Okay. And the third step?
Third, the model improves by analyzing your input alongside the inputs of millions of others. It does this to adjust its internal weights and probabilities. And finally, the fourth step is the deployment of a better, smarter AI back to you, the user, restarting the entire cycle.
And to make that statistical prediction engine actually work, the deck makes it very clear that these systems are absolutely ravenous. Like, they need an incredibly diverse style.
Yeah, they need everything.
Yet we aren't just talking about scraping a few encyclopedias here. The presentation categorizes this necessary data into 4 massive buckets. First, text and conversations. Then, documents and code.
Which is huge for logic.
Right. And then the third is images and media. And finally, user interactions. So it is essentially absorbing the absolute totality of human digital output to function.
Well, the variety is just as important as the volume,
Yeah.
An AI model learns different fundamental skills from different types of data.
Like what?
Well, if a system is only trained on, say, formal business documents, it will be completely incapable of holding a casual, empathetic conversation. It needs that first bucket, the text and conversations bucket, to map human tone, colloquialisms, and pacing.
Ah, I see. And the code helps with structure.
Exactly. It digests documents and code to learn structural logic, formatting, and step-by-step reasoning. Images and media provide the spatial and visual context necessary to understand the physical world.
But the most vital piece, right, the mechanism that actually bridges the gap between raw knowledge and practical human utility, is that fourth bucket.
User interactions, yes.
Right. The way you, the audience, react to the AI output is the ultimate behavioral feedback mechanism. Which brings us to a concept that, honestly, completely blew my mind as we move forward in the source material.
A human element.
Yes. I have to admit, I pushed back on this when I first read it. Wait, AI isn't purely automated? There are actual real human beings sitting in offices reading this stuff.
Surprising to a lot of people.
There is a stark visual here in the deck titled Human Trainers Behind the Scenes, showing a person at a dark workstation actively reviewing code and conversations.
It is perhaps the most heavily obscured mechanism in the entire industry. I mean, we are conditioned to imagine AI as this pristine mathematical brain operating in a void, untouched by human hands.
A magic box.
Right, exactly. But the reality is incredibly labor-intensive. Human reviewers are the structural guardrails of that continuous learning cycle we talked about. An algorithm cannot inherently know what is polite or helpful without a human initially defining those abstract concepts.
So what are these human trainers actually doing all day?
The deck outlines 3 distinct manual roles they perform. First, they review conversations. This means physically reading transcripts to flag problematic, hallucinated, or low-quality outputs so the system learns to avoid those neural pathways.
Like reading my actual chats.
Yep. Second, they identify harmful content, which involves catching toxic, unsafe, or biased responses to ensure the system doesn't generate dangerous material.
So mechanically, if someone is trying to trick the AI into providing instructions for something sketchy, the system might block it. But a human trainer might also be reviewing that specific interaction later.
Yes, to understand how the user tried to bypass the security, effectively patching the loophole. That is the exact mechanism of safety testing.
Wow. Okay, and what's the third role?
The third role is labeling training data. This is painstaking manual labor. It involves human annotators categorizing and tagging millions of data points to guide the model's understanding.
Tagging them how?
Well, if you feed a model a million emails, it just sees text. A human has to go in and label which emails are sarcastic, which are formal, which are aggressive. That exhaustive manual classification is what gives the automated facade its illusion of actual intelligence.
So that directly explains the mechanism of how our everyday prompts become training data. It's not that every single grocery list you type is automatically hardwired into AI's core memory.
No, not at all.
It's that patterns, behavioral examples, and edge cases are extracted by this system. The deck actually lays out 4 specific functions that our daily user inputs serve in this massive pipeline.
And they're all critical.
Right. 1. Error detection. Literally finding the exact parameters where the model fails. 2. Example conversations, providing authentic human dialogue for fine-tuning. 3. Safety testing, exposing the vulnerabilities we just mentioned. And 4. Quality data sets, raising the overall baseline of performance.
It's a massive feedback loop.
Let's put this in perspective for everyone listening. If you get frustrated because a chatbot completely misunderstood your request to write a funny wedding toast, and you type, "No, that's too formal, rewrite it to be self-deprecating," you are not just fixing your own output.
No, you're not.
You are actively doing free error detection and tone calibration for a massive corporation.
You are surfacing their blind spots in real time. A laboratory environment cannot simulate the organic frustration of a user trying to get a specific emotional tone for a wedding toast.
Right. A lab can't fake that annoyance.
Exactly. Your correction shows the model the exact mathematical distance between its initial prediction and the desired human outcome, which allows the engineers to sharpen the weights for all future responses.
Here's where the dynamic gets really interesting as we progress to the section titled, Why Real User Prompts Are So Valuable. I look at these massive tech companies. They have virtually unlimited computing power.
Billions in resources.
Right, billions of dollars in venture capital and revenue. If they need data so desperately to train these models, why can't they just build a separate closed-loop AI in a laboratory to generate synthetic test data? Why do they need my chaotic, poorly spelled 2 in the morning question about how to fix a leaky kitchen sink?
What's fascinating here is that the limitation lies in the mathematical nature of synthetic data. When an AI generates data to train another AI, it is essentially an Ouroboros, a snake eating its own tail.
It just loops back on itself.
Right. Synthetic data tends to be too clean, too logical, and entirely too predictable. It interpolates within known parameters. It targets the absolute center of the bell curve.
So it's boring.
Exactly. Real-world human prompts, however, do something algorithms struggle with. They extrapolate. The presentation identifies 4 core reasons why human chaos is the most prized asset. First, unexpected questions.
Because we ask weird things.
We do. Users combine concepts in ways engineers and algorithms simply never anticipate. Second, cultural context. Real human language is incredibly messy and constantly evolving.
Right. A synthetic generator in a lab isn't going to organically invent a brand new piece of internet slang, understand the irony behind a new meme, and start casually deploying it in a sentence. It needs us to inject that cultural shift into the system.
And that leads directly to the third reason. Edge cases. These are the highly improbable, rare inputs that live on the extreme fringes of the bell curve. Humans test the boundaries of a system simply by being unpredictable.
And the fourth reason.
Real problems. Authentic use cases from everyday life. Your chaotic question about a leaky faucet provides a grounded, physical world scenario that grounds the statistical engine in practical reality.
So, to our audience listening right now, your unique, weird, highly specific, context-heavy questions are exactly the oxygen this technology requires to survive outside of a sterile laboratory.
You are literally the engine.
You are the engine providing the cultural context and the unpredictable edge cases that make the AI actually functional for the public.
If we connect this to the bigger picture and look at the macro ecosystem, we see how this human chaos translates directly into staggering financial structures.
The cost must be unbelievable.
Building these systems requires astronomical capital. We are talking about billions of dollars dedicated solely to computing infrastructure, the massive energy-intensive server farms required just to keep the lights on.
Just to plug it in.
Basically, yeah. Then you factor in the unprecedented research and development costs and the ongoing expense of continuous large-scale training.
It is a massive financial sinkhole just to build the foundational architecture. So how does the industry actually recoup that investment? The presentation distills the AI business model perfectly. User data is the bridge.
It connects the two sides.
Right. The data closes the loop, turning a massive financial sinkhole into a highly competitive, lucrative commercial product.
The material explicitly defines high-quality training data as the industry's most prized asset because it is the sole differentiator between a mediocre model and an industry-leading one.
It's the secret sauce.
Exactly. This data dictates 3 fundamental pillars: the model's accuracy, its overall capability, and ultimately its market competitiveness. Because the model with the best data wins the market, the global ecosystem for AI training data is independently valued in the billions of dollars and is expanding exponentially.
It creates what the deck calls an infinite loop. Better data leads to smarter models. Because the models are smarter, they attract a wider user base.
Which means more data.
Exactly. That wider user base generates an even larger volume of diverse data. And that new data feeds right back into the system to make the models even better. It is a massive, self-sustaining flywheel.
But you have to ask where it all goes.
Yeah, the immediate question is, where is all this data actually traveling? That brings us to a highly complex flowchart in the material detailing the expanding AI ecosystem. It illustrates that your data does not just sit securely on one hard drive in one company's basement.
Not even close. The ecosystem is incredibly layered, and the routing of information is complex. The architecture is broken down into 4 distinct structural zones.
Okay, weigh them out for us.
At the base, you have the foundation models. These are the massive underlying cognitive engines. Above that, you have AI applications. These are the specific user-facing tools you interact with, maybe a productivity chatbot or a specialized coding assistant built on top of the foundation model.
Right, the apps on our phones.
Yeah. Supporting all of this is the cloud infrastructure, which comprises the physical servers, the data storage systems, and the application programming interfaces, or APIs, that connect everything. And finally, the training datasets themselves, the organized repositories where human interactions are stored and labeled.
I'm looking at this flowchart, and honestly, the implications are a bit dizzying. If I use a specialized AI writing app on my phone to draft a marketing email, my natural assumption is that my data stays entirely within that specific app.
Most people assume that.
But this ecosystem model shows something entirely different. The most crucial realization here, the underlying mechanic everyone needs to understand, is that each of these layers is independently capable of collecting, routing, or processing user data.
The journey of a single prompt is highly fragmented. You type your prompt into the AI application. That application logs your data. But to generate an answer, that app must send your prompt via an API call through the cloud infrastructure, which can also monitor the traffic.
Oh, wow.
Yeah, and then the cloud routes it to the foundation model, which actually processes the text and can retain it for future training. Your subtle question about an email subject line is bouncing through a labyrinth of distinct corporate entities and technologies before the answer ever appears on your screen.
So what does this all mean? It naturally brings up a massive issue for the end user. The material defines this as the transparency challenge. There is a powerful visual here in the deck, a glowing question mark trapped inside a glass server rack.
It's a great metaphor.
It really perfectly captures the current dynamic. We are all living our daily lives, interacting with this technology, leaning on it for work and creativity, but it operates as a complete black box to the public.
There is a profound mechanical disconnect between the user and the architecture. The vast majority of people interact with these systems completely blind to the routing and retention mechanics we have just discussed.
And it's not really our fault, is it?
No, and the presentation acknowledges that this isn't entirely a failure of the user. There are 3 major systemic transparency hurdles built into the industry. First, the actual mechanics of model development, how AI is trained, and what specifically goes into the data sets are rarely disclosed in plain language.
It's all jerk.
Exactly. Second, the policies governing how user data may be utilized are almost universally buried in terms of service agreements. These documents are highly technical, legally dense, and effectively unreadable for the average person.
Right. Nobody is sitting down to parse a 40-page legal document analyzing data retention clauses before they ask a chatbot for a chocolate chip cookie recipe.
Exactly the problem. And third, as the ecosystem flowchart demonstrated, users simply do not realize the sheer number of third-party entities involved in a single transaction. The assumption of a one-to-one relationship between the user and the software is a fundamental misunderstanding of the cloud architecture.
Because of that black box dynamic, the source material draws a hard line here. It emphatically lists 3 absolute realities that every single user must understand as a baseline for operating in the modern digital economy.
These are crucial.
If you take nothing else away from this deep dive, take these 3 facts. Number 1, prompts may be stored. You must assume the default setting for these tools is that your conversations, your typos, and your corrections are retained indefinitely. Number 2, interactions may train models. Your inputs actively shape the behavioral pathways of future iterations of the software. And number 3, data may cross multiple systems.
The labyrinth we talked about.
Right. Do not ever assume your conversation is a private, encrypted tunnel between your device and one single company. Third-party vendors and API pipelines are the standard infrastructure.
Acknowledging those realities brings us to a critical juncture. The final sections of the material pivot from the mechanical function of the technology to the broader societal adaptations required.
The big picture stuff.
Exactly. As these prediction engines become integrated into the fabric of daily life, society is being forced to answer defining generational questions regarding infrastructure and rights.
The deck actually outlines 4 massive societal challenges we are currently facing. First, data ownership. Who mechanically owns the output when human creativity merges with an algorithm?
That's a messy legal area.
Very messy. If I use my unique expertise to prompt an AI to write a brilliant piece of code, and that interaction is ingested to train the next version of the model, do I retain any ownership over that future system?
Unlikely right now.
Right. Second, transparency. What level of disclosure should be standard? Should companies be required to provide a clear ledger of whose data trains their models? Third, privacy protections. How do we establish robust legal frameworks to protect individuals in a digital ecosystem specifically designed to relentlessly scrape and process behavioral data?
And the last one is huge.
Yeah. Fourth, responsible AI. How do we ensure the architecture is ultimately built to serve the users rather than simply farming them for the raw material needed to fuel the continuous learning loop?
This raises an important question for the audience. What should you mechanically do differently the next time you sit down at your keyboard?
Give us some advice here.
The presentation concludes by translating these massive concepts into actionable advice. First, protect your information by treating the prompt box as a public forum. You must make deliberate choices about what you introduce into the system.
So no social security numbers.
Definitely not. Never input sensitive personal data, proprietary corporate strategy, or private health information into a generalized AI tool, because you must assume it enters the continuous learning loop.
Okay, what else?
Second, evaluate and choose the right tools. Do not just look at the speed or capability of a model. Look at the data architecture. Seek out applications that explicitly offer opt-outs for data training and clear retention policies.
Read the fine print, basically.
Or find tools that make it easy not to. And third, use AI responsibly. Engage with the ecosystem not as a passive consumer dropping a coin into a vending machine, but as an informed participant who understands the exact commercial value of their own behavioral data.
It truly requires a complete paradigm shift. We have to stop thinking of ourselves as merely the users of AI software. Mechanically speaking, we are simultaneously the developers, the quality assurance testers, and the raw product itself.
We are the whole loop.
We really are. The multi-billion-dollar data economy behind artificial intelligence is running entirely on the continuous combustion of our collective, everyday output.
It's a sobering thought.
It is. But processing all of this leaves me with one final, lingering thought. Something for everyone listening to really mull over as you go about your week.
Let's hear it.
We talked extensively earlier about how these AI systems desperately require our chaos. Our unexpected questions, our shifting cultural context, our beautifully messy human extrapolation to survive.
Right, to avoid that synthetic Ouroboros.
Exactly. We established that synthetic, lab-generated data has hard mathematical limits. It creates an Ouroboros that cannot innovate. But, and this is the big question, if our real chaotic human inputs are the absolute most valuable resource for training the next generation of AI, what happens mechanically as we increasingly rely on AI to write our emails, to brainstorm our marketing campaigns, to code our software, and to draft our documents?
It's a paradox.
It is. What happens to this massive data economy when the human chaos it desperately feeds on is eventually replaced by a continuous automated feedback loop of AI-generated perfection? Are we eventually just going to be talking to echoes of our own synthesized data?
That is the multi-billion-dollar question the architecture has yet to answer.
Thanks for joining us on this deep dive, everyone. We will catch you next time.